Assalamualaikum warahmatullahi wabarakatuh. Hi, welcome back to my channel. How are you? I hope you're doing well. So this time, I made this video as the midterm assessment assignment, and this video will talk about 5 topics of mathematics subject, that is GCF and LCM, power, roots, logarithm, and sequences. So let's get started.
Greatest common factor, or GCF. GCF is the sum factors of two or more numbers, the largest number among its common factors. Lowest common multiple. LCM is the sum multiple of two or more numbers, the smallest number among its common multiples. The GCF and LCM can be solved using prime factorization. Prime factorization is the process of expressing an integer as the product of the prime factors. Prime factors are factors that contains prime numbers. An easy way to determine prime factorization is to use a factor tree or pohon factor, which is to divide the number so that only the prime factors are left. For GCF, we can determine it by product of the same factors and take the factor with the smallest power. And for LCM, we can determine it by product of all factors and take the factor with the greatest power for the same factor. Example number 1. Find the GCF of 12, 18, and 30. Solution. Prime factorization of 12 equals 2 raised by 2 times 3. 18 equals 2 times 3 raised by 2. 30 equals 2 times 3 times 5. So the GCF of 12, 18, and 30 is 2 times 3 equals 6. Number 2. Find the LCM of 20, 24, and 72. Solution. Prime factorization of 20 equals 2 raised by 2 times 5. 24 equals 2 raised by 3 times 3. 72 equals 2 raised by 3 times 3 raised by 2. So the LCM of 20, 24, and 72 is 2 raised by 3 times 3 raised by 2 times 5 equals 8 times 9 times 5 equals 360. Number 3. Find the GCF and LCM of 48, 60, and 96. Solution. Prime factorization of 48 equals 2 raised by 4 times 3. 60 equals 2 raised by 2 times 3 times 5. 96 equals 2 raised by 5 times 3. The GCF and LCM of 48, 60, and 96 is 2 raised by 2 times 3 equals 4 times 3 equals 12, and 2 raised by 5 times 3 times 5 equals 32 times 3 times 5 equals 480. Example number 4. Lamp A flashes every 8 seconds. Lamp B flashes every 12 seconds. Lamp C flashes every 15 seconds. If at this time all three lights flash together for the first time, at what second will the lights flash together for the second time? Solution. This question is about LCM. So prime factorization of 8 equals 2 raised by 3. 12 equals 2 raised by 2 times 3. 15 equals 3 times 5. So the LCM of 8, 12, and 15 is 2 raised by 3 times 3 times 5 equals 8 times 3 times 5 equals 120. So all the three lights will flash together for the second time at 120 seconds or 2 minutes. Number 5. And the framework of the Independence Day of the Republic of Indonesia, the committee received donations of 84 notebooks and 35 pens for children's competition prizes. Each prize pack for the winner of the competitions has the same amount of content. How many gift wraps can be made? Solution. This question is about GCF. So prime factorization of 35 equals 5 times 7. 84 equals 2 raised by 2 times 3 times 7. The GCF of 35 and 84 is 7. So many gifts can be made as 7 packs. Powers. Powers is used when we want to multiply a number by itself several times. The word power sometimes also means the exponent alone rather than result of exponential expression. Examples and solutions. Number 1. A to the power of 5 times a to the power of 7 equals a to the power 5 plus 7 equals a to the power of 12. Number 2. M to the power of 8 over m to the power of minus 2 equals m to the power of 8 minus negative 2 equals m to the power of 10. Number 3. X to the power of 3, y to the power of minus 4, and the parenthesis to the power of 2 times x y squared and the parenthesis to the power of minus 3 equals x to the power of 6 y to the power of minus 8 times x to the power of 3 y to the power of minus 6 equals x to the power of 9, y to the power of minus 14 equals x to the power of 9 over y to the power of 14. Number 4. Minus 12 r to the power of minus 9 s to the power of 10 all over by 4 r to the power of minus 12 s to the power of 7 equals minus 3 r to the power of 3 s to the power of 3. Number 5. 10 to the power of 12 minus 10 to the power of 11 all over by 9 equals 10 to the power of 11 times 10 minus 1 in the parentheses all over by 9 equals 10 to the power of 11 times 9 all over by 9 equals 10 to the power of 11. Roots. Roots is inversion of exponentiation, and root of x is called radical expression or radical form because it contains a root. Examples and solutions. Number 1. Fourth root of 81 equals 3. Number 2. 121 to the power of 1/2 equals squared root of 121 equals 11. 3. Number 3. 6 root of 25a squared equals 6 root of 5a and the parenthesis to the power of 2 equals 5a and the parenthesis to the power of 2 over 6 equals 5a and the parenthesis to the power of 1 over 3 equals cubed root of 5a. Number 4. 4 cubed root of 6 times 2 cubed root of 18 equals 8 times cube root of 108 equals 8 times cubed root of 27 times 4 equals 8 times cube root of 27 times cube root of 4 equals 8 times 3 times cubed root of 4 equals 24 cube root of 4. Number 5. Cube root of 54 plus cube root of 16 minus cube root of 250 equals cube root of 27 times 2 plus cube root of 8 times 2 minus cube root of 125 times 2 equals 3 cube root of 2 plus 2 cube root of 2 minus 5 cube root of 2 equals 3 plus 2 3 plus 2 minus 5 in the parentheses times cube root of 2 equals 0 times cube root of 2 equals 0. Logarithm. Logarithm is the inverse of an exponent. A to the power of x equals b. Equivalent. X equals log to the base a of b. Examples and solutions. Number 1. Log to the base 3 of 6 plus log to the base 3 of 4.5 equals log to the base 3 of 6 times 4.5 in the parentheses equals log to the base 3 of 27 equals log to the base 3 of 3 raised by 3 equals 3 times log to the base 3 of 3 equals 3 times 1 equals 3. Number 2. Log to the base 4 of 128 minus log to the base 4 of 8 equals log to the base 4 of 128 over log to the base 4 of 8 equals log to the base 4 of 16 equals log to the base 4 of 4 raised by 2 equals 2 times log to the base 4 of 4 equals 2 times 1 equals 2. Number 3. Log to the base 27 of 125 equals log to the base 3 raised by 3 of 5 raised by 3 equals 3 over 3 times log to the base 3 of 5 equals 1 times log to the base 3 of 5 equals log to the base 3 of 5. Number 4. Log to the base a of b times log to the base b of c squared times log to the base c of a cubed equals log to the base a of c squared times log to the base c of a cubed equals 2 times log to the base a of c times log to the base c of a cubed equals 2 times log to the base a of a cubed equals 3 times 2 times log to the base a of a equals 6 times 1 equals 6. Number 5. If log to the base 2 of 7 equals m, then log to the base 8 of 49 equals log to the base 8 of 49 equals log to the base 2 raised by 3 of 7 raised by 2 equals 2 over 3 times log to the base 2 of 7 equals 2 over 3m. Number 6. If log x plus log 5 equals log x squared minus log 14, then x log 5x equals log x squared over 14. Equivalent 5x equals x squared over 14. Equivalent 70x equals x squared. Equivalent x equals 70. Sequences. Sequence is a set of things that are in order. When the sequence goes on forever, it is called an infinite sequence. Otherwise, it is a finite sequence. Arithmetic sequence. UN equals A plus n minus 1 in the parentheses times d. Un is an term formula. A is the first term, nth term when n could be any term number. D is common difference. Example number 1. First term 7, 10, 13, 16, 3 dots. Give the expression of nth term. From the sequence, we know that A or first term is 7. D or common difference equals 10 minus 7 equals 13 minus 10 equals 16 minus 13 equals 3. So the answer or n equals A plus n minus 1 in the parentheses times d equals 7 plus n minus 1 in the parentheses times 3 equals 7 plus 3n minus 3 equals 3n plus 4. Number 2. First term 3. 3 plus square root of 3. 3 plus 2 square root of 3. 3 dots. Give the next two terms. We know that first term or A equals 3. And for D, you can subtract the second term from the first term and then the third term from the second term. And we get D equals square root of 3. Answer or UN equals A plus n minus 1 in the parentheses times D equals 3 plus n minus 1 in the parentheses times square root of 3 equals 3 plus square root of 3 n minus square root of 3 equals square root of 3 n plus 3 minus square root of 3. So the next two terms is for fourth term and fifth term. Fourth term equals square root of 3 times 4 plus 3 minus square root of 3 equals 4 square root of 3 plus 3 minus square root of 3 equals 3 plus 3 square root of 3. fifth term equals square root of 3 times 5 plus 3 minus square root of 3 equals 5 square root of 3 plus 3 minus square root of 3 equals 3 plus 4 square root of 3. Number 3, first term minus 2, 5, 12, 3 dots. Find 100th term. A equals minus 2, D equals 5 minus 2 in the parentheses equals 12 minus 5 equals 7. So the answer equals minus 2 plus n minus 1 times 7 equals minus 2 plus 7n means 7 equals 7n minus 9. The 100th term equals 7 times 100 minus 9 equals 700 minus 9 equals 691. Number 4, first term minus 15 minus 11 minus 7, 3 dots, and term or UN equals 181. Find n. A equals minus 15, D equals 4. You can subtract the second term from the first term and the third term from the second term. Then n term or UN equals A plus n minus 1 times D UN equals minus 15 plus n minus 1 in the parentheses times 4 UN equals minus 15 plus 4n minus 4 UN equals 4n minus 19. 181 equals 4n minus 19. So 4n equals 181 plus 19. 4n equals 200. So n equals 50. Example number 5. n equals n minus 1/2. Find the first term and common difference. There is a formula as follows. Un equals dn plus c, where c equals a minus d. Maybe wondering where did the formula come from. Now look at this box. We know that un equals a plus n minus 1 in the parentheses times d. Un equals a plus dn minus d. Un equals dn plus a minus d. Un equals dn plus c. We can replace a and d with the constant. From the question, we know that d equals 1, c equals A minus D. Minus 1/2 equals A minus 1. A equals minus 1 over 2 plus 1. So A equals 1/2. So the first term is 1/2 and the common difference is 1. Thank you.
So this is the end of the talk. Hope you like it and this can be useful. I'll see you in the next video. Bye bye.